So let's proceed with the event for the last talk of today. So I think we have Paloma online, I hope.
Hello. Hi. Can you hear me?
Hi, Paloma. How are you? Nice to meet you.
Hi from London.
I'm just doing a quick introduction so everyone gets to know you a little bit. So Paloma Gormley, co-founder of Material Cultures, is an internationally acclaimed designer responsible for a series of celebrated architectural and urban projects. Her design work exhibits a playful pragmatism and is underpinned by an interest in the processes by which things are made. She founded Practice Architecture with Lettice Drake in 2009, with a focus on community and cultural projects such as the Yard Theatre and Bold Tendencies. Paloma led the design and system development of Flat House, a groundbreaking prefabricated house made from hemp. In order to progress this work further together with Summer Islam, she established Material Cultures, a not-for-profit research organization working at the intersection of post-carbon materials and contemporary construction technology. Paloma co-runs Construction in Detail in the Spatial Studies Department at the University of Arts London and has taught at Bartlett University College London and the London Metropolitan University. Well, thank you, Paloma, for being here. Now we'll give you the stage, and in the end we'll do some questions and answers. Thank you.
Thanks for the introduction. I'm just going to share screen. So hello, my name is Paloma Gormley. I'm a founding director of Material Cultures, which I run together with Summer Islam and George Massoud. We're a not-for-profit design organisation and we work at the intersection of natural materials and low embodied carbon construction and technology. Our work encompasses advocacy through design and curatorial work, where we can demonstrate the beauty, the adaptability, and the practicalities of working with low embodied carbon materials, as well as the extraordinary impact that they have on the thermal performance and embodied carbon of our building stock. Sorry, I lost my way. They also have extraordinary potential to make beautiful contemporary buildings. We teach currently between the three of us, both at Central St Martin's and the Architectural Association. In this project, which is called Carbon Copies, our master's students investigated the impact of translating a series of iconic residential typologies into a fully bio-based low carbon material palette, building fragments of them at 1:1, which you can see here. We also design buildings and construction systems, and systems that can be applied at scale to new build developments. So we work with clients to develop urban propositions which can be integrated into off-site fabrication strategies, working with regional bio-based material supply chains. We also carry out research, so into materials and their application in construction, as well as their impact on our culture and our landscape. So to give you a bit of context of our work, we're looking to support systemic change in the construction industry. And for the last 50 years, we've been using crude oil to try and solve the problems of sustainability in architecture. Our construction industry has produced a multitude of oil-based insulating and high-performance products, from polyurethane and polystyrene insulations to nylon thermal resistors, PVC, airtightness membranes, etc. And we develop construction technology using materials like steel and aluminium and glass, whose availability is dependent on a vast quantity of cheaply available oil, such as air conditioning systems, heat recovery units, triple glazing. These technologies are neither durable nor are they expected to last. Most contemporary buildings require specialist knowledge and equipment to maintain, knowledge that's easily lost, often economically inaccessible to people, and depending on parts that readily go out of production. This technification of architecture has concentrated power in the hands of the technocrats. Our current material culture transforms vast quantities of extracted material into vast quantities of waste, and it does so extraordinarily efficiently. This is the oil age of architecture. The circular economy is the idea that in order to think meaningfully about sustainability in relation to human production, we need to consider the entire life cycle of everything that we produce. And embedded in this are three key material cycles, so composting, recycling, and reuse. William McDonough, who wrote Cradle to Cradle, the founding text of the circular economy, recently developed the Innovation for Circular Economy House, which you can see here. It's a building system made entirely of polycarbonate, aluminium, and aerogel. These very high energy and very high carbon materials are justified by the idea that the system is designed to be demountable, meaning it can be reassembled at a later date elsewhere. Due to the number of components and their complex dependencies, implementing reuse and recycling in construction in a meaningful way represents an immense and potentially insurmountable logistical challenge. Ultimately, it demands vast warehouses, distribution networks, and mass standardization. It must also acknowledge the inevitable entropy and significant loss of energy, carbon, functionality all along the way, and the significant energy required to redistribute and recycle elements. Yet it is interesting that of the three cycles, composting, recycling, and reuse and recycling seem to be receiving the most investment. Why? Perhaps because reuse and recycling maintains the logic of capitalist growth. The often fanciful narrativization of the future justifies the continued use of the high energy materials that we've become so dependent on, and allows us to maintain the status quo. These narratives often ignore the inevitable externalities of these processes. So every time, for example, that we recycle plastics, we reintroduce particles into our waste streams, into our environments, and into our oceans. We are fast learning that we need to remove plastic from our material cycles, not perpetually reintroduce them. Reuse and recycling very quickly become highly technocratic. Standardization means fewer authors, and we lose sight of architecture as a crucial mode of cultural production, and further consolidate the almost total monopoly of the white, male, and technocratic author. Or perhaps, as Bell Hooks might say, in this move towards standardization, you can see the mechanisms of the white supremacist capitalist patriarchy at work. The reality is that the circular economy is not possible with the materials that we currently depend on. So what's the alternative? And how do we respond to the evolving needs of society without the disastrous effects of our current modes of production and growth? This is how nature deals with waste, through composting, fermentation, microbial digestion, and decomposition. These processes reintegrate matter into natural carbon cycles, where it has the ability to regenerate and regrow. At Material Cultures, we are interested in what happens when we work with construction materials that can remain part of biochemical and nutrient cycles. A mode of construction where at the end of the life, the constituent parts of a building could simply return to the ground. In this mode, materials are not contaminants, they come from and they belong to the landscape. And this is how things were made for thousands of years. Biological processes such as anaerobic digestion can transform waste into things like biogas, which is already happening at scale across Europe. Limes and clays have for centuries undergone careful fermentation processes in order to condition them and improve their performance. This is material technology that is also at risk of being forgotten. These materials have an inherent plurality. They can accommodate many authors and unlimited standards. In fact, bio-based materials generally sequester rather than generate carbon. They're accessible, they require few specialist tools, and you can work with simple detailing in construction and there is often something intuitive about working with them. They allow architecture to be culturally generated and perhaps suggest a different type of relationship to a building, situating architecture in relation to care. A care which requires human investment and a different set of relationships to place and the formation of new cultures. Bio-based materials can be produced efficiently at a regional scale and integrate with existing crop cycles. So the other implication is the possibility of architecture to rebuild a direct relationship to place. This means things traveling less far and therefore it being easier to return and to assimilate them back into the ecosystem. In this way, you can see building as a gathering up of bits of the landscape. Coming straight from the ground, these materials invite direct contact, experimentation, and play. And this is at the center of our practice, material cultures, as there is still a huge amount to learn and to relearn. Perhaps this direct relationship with materials is a way for us to find new languages that have the potential to supersede those we've inherited from a historically narrow lineage of authors. Our approach might be considered Arcadian, but we're also interested in the role of contemporary tools and modes of construction, meaning building off-site where practical and working with efficient forms of mass production. The problem itself is massive and it needs to be met at scale. So in order for change to come quickly enough, the status quo needs to be challenged on ecological and economic terms. This means embracing digitalized construction processes where repetitive, non-specialist labor is carried out by machines. And off-site, we have the ability to improve working conditions, change cultures, and to reimagine factories as sites of creativity and cultural production. So from our work over the last decade, we've developed a set of principles. These are around the kind of monolithic construction, so moving away from this kind of contemporary, very layered mode of making buildings. Thinking about sequestration wherever possible, so building in bio-based materials that sequester carbon over their kind of growth span, which is then locked away in the fabric of the building. Breathing construction, so buildings historically all used to breathe, and it's only relatively recently that we introduced kind of membranes and this idea of non-breathing construction. So returning to breathing construction, which also brings kind of passive regulation of humidity and all kinds of other benefits. Building resiliently, so rather than using kind of toxic intumescent coatings, thinking about how the materials themselves can have integrity in response to fire and other kind of environmental conditions. And making buildings compostable. So ideally, components of the building would be recycled, but ultimately at the end of their life, the materials that we use, we aim for them to be returned to the ground as compost. And then scalability, this is really at the core of what we do. So kind of using experimental projects to think about how these ideas can kind of go mainstream, essentially. So one of the things that needs to happen in terms of kind of architectural design process is rethinking at what stage of an architectural process different things happen. So a key thing for us is shifting the specification of materials much earlier on in the design process. Understanding the capacities and limitations that are of the materials that are regionally available. So this might, for example, mean designing a structure around a greater number of smaller timbers rather than fewer larger timbers. So the material availability begins to determine an overall construction system and the logic for construction. And in looking to design out concrete wherever possible, we're developing alternatives for foundations that respond to geology using materials such as chalk, for example. And we're working with organisations such as Local Works in the UK to further explore the potential of chalk for cladding and finishing applications. Beyond timber, we've been working with a variety of bio-based feedstocks, Unlike trees, these crops are measured in, the crop cycles are measured in decades. So materials like straw and hemp are harvested annually. And hemp in particular has an extraordinary capacity for sequestering carbon, both in the plant matter above ground, but also they recarbonize the soil with their long tap roots. The stem of the hemp plant is composed of a woody core known in construction as the sheaf or herds, and an outer layer of fiber. When you combine lime and hemp sheaf, you get a crude monolithic material known as hempcrete. This can be cast into blocks and laid with lime mortar as if they were cement blocks. It can also be cast in situ against shuttering. The sequestered carbon is held in the organic matter until the end of the building's life. The sheaf holds the air and acts as an insulator and gives mass and bulk to the material, and then the lime binds the sheaves together and makes the mix highly fire and mold resistant. The fiber has any number of applications. It's used in textiles, it's used in rope, it's incredibly strong and durable, and we've been working with it in other applications such as cladding, working with kind of bio-based binders. So for Flat House, we explored this cassette-based system. So there are limitations with casting in situ. It brings a kind of wet and messy specialist trade to site, and the drying times also limit the seasonal construction window, and they elongate programs due to long kind of curing times. You can't apply the kind of finished layers sometimes for months. So we developed a system of precast panels that can be made in the factory, and this means they can be pre-dried and assembled on site in a matter of days. We're developing proposals for how these ideas that we developed for Project Flat House can be applied on an urban scale. Looking at how on-site microfactories can produce the construction components and how modular systems can be used to create rich and varied streetscapes. Places with character and texture that can support many forms of life, and that rather than degrading over time, they age beautifully. But are we beckoning in a new era of ever more intensified industrialized agriculture? And can this be mitigated? What other non-human systems are dependent on the landscape, and how can we maintain them in the process? Last year, we worked with the North East and Yorkshire to develop a strategy for bioregional construction economy. We looked at how to enable the production and take-up of bio-based products and how agroecological processes might be integrated into this transition and what their impact might be on our landscapes. The report was developed collaboratively with our partners Arup, and the research looks at the viability of the circular and bio-based construction economy from the potential benefits of a transition, as well as the limitations of the one today. We also looked at the actions that the industry needs to take to achieve a cleaner, decarbonised construction industry and to bring about systemic change. We looked at how you can begin to quantify these benefits. So we started with counting and a detailed analysis of the local plans of the 31 local authorities within the North East and Yorkshire. It's estimated that approximately 30,000 homes need to be built annually, or 500,000 homes by 2038. In embodied carbon terms, and using today's benchmarks, this would generate more than 26 million tonnes of embodied carbon. So we looked to develop a model through which we could assess the potential long-term impacts of a bio-based industry. And so we picked as our subject a new build 3-bedroom semi-detached house, analysing the impact of this generic type of suburban home on the landscapes of the region. We carried out our analysis by reviewing the impact of switching out 3 crucial material applications in the building: the structure, the insulation and lining, and the lining. Many of the findings set out are directly applicable to retrofit projects as well. So we carried out an embodied carbon assessment on the superstructure of both the business as usual and the bio-based small-scale residential home. Both the business as usual and the bio-based homes were designed to contemporary building standards, so they had the same kind of level of thermal performance. So on the left, you can see a breakdown of the embodied carbon and the associated sequestered carbon for each of the designs. And on the right, you can see the net embodied carbon associated with these components, i.e. the embodied carbon subtracting the biogenic contribution. So a bio-based and circular economy would support the region and the country in decarbonising. Building 500,000 homes with bio-based materials instead of conventional ones could save nearly 3 megatons of carbon emissions. We know these materials can also help to create healthy environments, not just in the final buildings, but also for people throughout the supply chain. Finally, we identified that the bio-based material supply chain would give the opportunity to create jobs, improve skills, and improve skill sets where this is needed the most. The future of decarbonised built environment depends on previously disconnected industries working together to facilitate systemic change. Our question now is, how can the competing demands on our landscape be reconciled in this post-carbon future? And how can deforestation and afforestation serve us and our landscapes ecologically? Thank you very much.
Thank you, Paloma, for your talk. Now we can move for some questions from the audience. Anyone has a question?
Hi, Paloma. Thank you.
Hello.
No questions?
Who wants to start? Sonia.
Hi, Paloma. I think we already met, but it was on a Teams ICANN meeting. Do you remember in December?
I do, I remember. Nice to see you again.
Me too. I just wanted to know more about how working your think tank, or how do you say association, and how do you work together? And because you say it's a non-profit, so how could you work on a project and go on research in the same time, just to really understand how it's working?
So we work on a not-for-profit basis, which means any profit that we do make is essentially kind of ploughed back into the organisation and often into kind of other research that we're undertaking within the studio. And I guess that keys into our work with universities and institutions. So a large portion of the work that we do is in collaboration with universities. So we work with students to kind of generate research and research agendas and research outputs. So the project that we ran last year, Carbon Copies, was very much kind of co-produced with students at Central St Martin's. And then in terms of the kind of other projects, where there is a strong kind of research component to what we're doing, that work will be undertaken by material cultures, but we're also in the process of establishing another organisation, Material Homes, which essentially will begin to put these principles into reproducible home designs that we can then be kind of built by developers at scale. So I think we're really interested in how all of these ideas can be applied in the kind of real world. So there's, I think, a really rich and exciting relationship between this kind of research generating body, and then the potential for that to kind of interact with a more commercially driven organization. The way that those two companies are structured at the moment is that 80% of any profits that are made by the kind of material home side and then plugged back into material cultures to fund more research. So essentially everything is just forwarding the agenda of kind of, yeah, making this kind of construction more viable and more accessible.
Thank you. More questions? No?
No? Well, then I'll make another one. So, Paloma, with your presentation, it was clear the advantage of these bio-based material strategies, especially with that input of the amount of houses that you need to build and the difference between business as usual and applying bio-based material. My question is how can you input this idea with developers, and do they accept it? So how do you say? Are you convincing them to do it?
A few, yes. Or they're coming to us because they're already kind of, on the right path. And I think really what it's going to take is a few things. These kind of brave individuals or companies that are kind of leading the way. The developers I'm talking about. It's going to take a couple of these larger scale developments, I think, before the others follow. But that's why we're really interested in companies like kind of, the big Barratt Homes and Taylor Wimpey, etc. And the end game of all this really is that that everybody would be building with these materials as a default, and that they really are competitive in terms of cost and in terms of carbon. I mean, there's no reason they shouldn't be, other than that all of the kind of investment in production over the last 20-30 years has gone into completely unsustainable construction methodologies, and it means that they can operate much more efficiently at scale. And that seems to be the biggest hurdle, I think, at the moment, is getting, how do you, it's kind of catch-22 or kind of chicken and egg situation of how do you get this industry up to speed? And in the end, I think everything has to happen in parallel. Much more kind of material testing. There's these kind of demonstrator projects, but also kind of regulation to kind of force the hand of the industry into the transformation, into the transition.
Well, this actually reminds me of another question. Here in Portugal, we have, how do you say, not a setback, but a challenge, which is regarding the rules of construction. So if we want to do a hemcrete wall, we can do it, but there will be some constraints regarding the regulations and the tests of the material because, well, there are no tests. So even though we know they work, we can't use them, and sometimes it might be frustrating. I don't know how it works in UK. Is this established? Do you have at least some regulation that allows to use this in public buildings, for example, or
there are
in the same spot as us?
It's a similar situation. I mean, there's test results that exist for, generally they're tied to the binders. So for hempcrete, for example, so it's tied to the specific mix of lime, and they have been tested with generally a kind of few standard construction types. So I mean, we've managed to build just in reference to those standards, but there's a huge amount of testing that needs to be undertaken still in order for, I think, people to get really comfortable. And that testing is kind of relevant at every point in that, it's what it's what the insurers want to see, it's what the mortgage providers want to see, it's what the developers want to see. There just needs to be a massive drive, I think, behind just demonstrating how well these materials outperform the ones that we've become, got used to using, because they do almost in every different context. They perform so much better, actually.
Yeah.
Last longer.
See it to believe it. No?
Yeah, exactly. So I mean, in the UK, sadly, we had an organisation, BRE, that would have been perfect to lead on this process, and it was a public organisation that sadly got privatised. But yeah, some kind of, it'd be great if there was kind of pan-European drive to just set up a big program of testing and demonstrating, because it needs to happen fast, really.
Okay, perfect, thank you. Any more questions from the audience here?
No questions.
No? Okay, so Paloma, thank you very much for being with us.
Thank you, Paloma.
To talk with us from London. I hope you enjoyed the event. Of course, we did. So we hope to have you here next time, for sure. So, thank you,
Absolute
Paloma.
pleasure, and sorry not to make it, but thanks for having me.
Bye.
Bye. Thank you.
Bye.